Hello, welcome to my second video on trigonometric equations. So we can start with writing the title, Trigonometric Equations, part 2. In this video I will solve 3 more equations to show you what kind of different equations, trigonometric equations you can get, what formulas you might need to use. So in the previous video I talked about how we read the functions, so how we read which angle has that specific number, which angle has this sinus or cosine. Sine or cosine, sorry. And today I'm going to show you 3 more equations, and we will take a look at them and see what we have to use, which formulas, which theorem. Right, so let's start with the first one. Okay, let's go. So this is it. Sine 2x plus square root of 3 sine x equals to 0, and they want us to have the solution from the interval from 0 to 2 pi. So again, as we talked about it in the previous video, when we have this condition, so we have an interval, we don't have to think about function like sine as an infinite function, right? Because let me just draw very quickly, just to show you what I mean. So sine x is an infinite wave, right? Okay, this is totally not correct, but forgive me. Let's say it's perfect. So it is perfect wave, which is between -1 and +1, and it just goes on forever to the left and to the right. So if we don't have an interval for x, then we have to remember that it is a periodic function with a period 2 pi. And then we have to deal with it. But most of the equations, they will have this condition, right? So you will be asked to give your answers only from this interval. So it is much easier for us, and it will be much better. Okay, so let's try and solve this equation. So here we have a formula for sine double angle, right? So we have a formula for this, and it's 2 sine x cosine x plus square root of 3 sine x. Alright, so that's much better. We have x everywhere. So now, as you can see, we have sine x in both both numbers. So what we can do, we can take this sine x before the brackets, in front of the brackets, and then we get 2 cosine x plus square root of 3 and equals to 0. And here we have multiplication, which is really good, because now the only thing we have to do, we have to equal sine x to 0, or this bracket equals to 0. So we get 2 simple equations. So the first one is sine x equals to 0, or 2 cosine x plus square root of 3 equals to 0. And now we have to solve these 2 very simple trigonometric equations. So let's look at sine x. We have here my lovely drawing of sine x, so we can easily see that sine x equals to 0 for 0. Then we go here and we have for pi, and then for 2 pi, right? And because we have this interval, then of course we will have these three answers. So x, we can write here, okay, x belongs to the set, and we have 0, pi, 2 pi. So that's the first equation. And the second equation, well, what we have to do, well, some small work. So let's take square root of 3 to the other side and divide it by 2, and we get cosine x, and we get negative square root of 3 by 2. So we have a negative number, so we will have to take a good look at the function. Maybe this time I will not draw enough of my lovely drawings. I will use the function. Right. Okay, but I have to just get out of this presentation for a moment, and let's look for a cosine. Here we have cosine. Okay, so okay, let's use our cosine. Right. Okay. Let's take a look. Right. Okay, so this is our function, and we are looking for the number negative square root of 3 by 2. So of course, first of all, we have to remind ourselves, which angle has cosine alpha, let's say, square root of 3 by 2. First, we need to think about a positive number, because then we will easily find the negative one. But let's start with positive. So this is exactly which angle? It's exactly 30 degrees. So it's pi over 6, right? P6. If we have pi over 6 is exactly here, right? So this number here is this square root of 3 by 2, but we need negative 1, so we have to go, this function is very symmetric, so this point that we're looking for is going to be here, right? So we have to take the same length here, the same length here. So we have this point, and then of course this point will be here too, with a negative square root of 3 by 2. So here we have, just like somewhere here, we have negative square root of 3 by 2. Okay, so now let's find these 2 points. So we need to take, like, this one will be pi minus, and now take a look, because this small one, like, let's say one distance is pi over 6, so it's pi minus pi over 6, and this one will be pi plus pi over 6, right? So is it 6 or right? Okay, let me just take a look. Is it correct? Fine. Okay, this is cosine. Just let me check if everything is alright. Something I kind of feel that I'm missing here something. Okay, so cosine is part 6, and here we have third. Right. Let me just take a look here, just to make sure everything is just simply alright. as far as I have just a little bit different answers, and I just want to make sure I make it properly. Yeah. So is it pi over 6, 30, or is it? I guess it looks good. I mean, the answers that I have in the book are a bit different because they subtract and add pi over 3, which is a bit weird because it's pi over 6, right? Right. I hope it's correct because now I'm a bit confused and and blustered. So if you see any mistake, please let me know. Then we will correct this. So as far as I can see that, here we have x belongs to 5, 6, pi and 7, 6, pi. So we have 5 answers, 3 here and 2 here. So together 5 possibilities, 5 answers to this question, to this equation. Okay. Okay, hopefully it is cosine, right? Okay, so this is cosine function, and it's exactly right, because for pi over 3, so for 60 degrees we have 1/2, so this is pi over 6, and here we have yep, I think so. Okay, let's go. Number 2. Sorry for my confusion. I just got there are another answers in the book, but of course it's possible that they have they have mistake. Okay, let's go to the second equation. Second equation looks like this: 4 times sine 7x times cosine 2x equals to 2 sine 9x minus 1, and the interval is even shorter than before because it's 0 pi. Okay, so again, quite good information for us because we don't have to look at the period of the function, so we have just 0 pi. Now let's take a look here. Well, this is a bit different equation than the previous ones because we have like 7x, 2x, 9x. So the argument here is a bit different, and of course we need some formulas. So you should be careful if you have like different numbers. You should just look at them. If they might give you, like if you add them, you will get something else. So as you can see, 7x plus 2x is going to give 9x. So there is a chance, very good chance, that we can use some formula here to get this 9x. And I'm going to show you the formula. Just let's take a look here and take this formula. It is here. So let's take a look here because there are quite a few formulas. So we're going to look at them. Okay. Yeah, take a look here. So we have if we add two sinus, right, then you have sine of the sum by 2 and cosine of the difference between the angles divided by 2. So these are formulas for sum and subtraction. Right, but there is also so you have to just notice some possibilities here. So if we put here, can you imagine this one as 9x and this one as 7x, not 5x, sorry, 5x. So also we should see here that there is a possibility here, because if we put 9x and 5x here, let's see what we get. It's 2 sine, then we have 9x plus 5x by 2, and times cosine 9x minus 5x by 2. And let's take a look what we get. It's sine, it is 14 divided by 2, so it's 7x times cosine 4 divided by 2, 2x. So that's a pretty good thing, because it's exactly what we have here, you see. So of course it's you have to take a good look and just try to put it here, try to put it there, just see what you can get, because usually you just don't see it straight away. But it's really important to see that you can get this part to get 9x. But as you can see, we couldn't use 7x and 2x, because then we would need to divide it by 2, so then we would have a problem with 4.5x. So we're going to use this one, and then we can do it like this. So let's go back to our equation. So it's 2 times 2 sine x cosine 2x, right? So this is the whole part. Then 2 sine 9x minus 1. And then instead of this expression, we will put this expression, right? So 2 times sine of 9x plus sine of 5x. And the right side is unchanged. And there we go, 2 sine 9x plus 2 sine 5x. And the right side unchanged. And look, beautifully we get rid of this part, and what we have is 2 sine 5x is negative 1 divided by 2, of course, and then we get sine 5x is negative 1/2, which is really good. So we have at the end we have very simple trigonometric equations. So we have sine 5x equals to negative 1/2. So now we have to take a look at the sine function. So let me just write again here. So sine 5x equals to negative 1/2. And we need another function. We need sine x. So let's take sine x now. Okay. Okay. Right, so we have function. Okay, and here we have 5x, not x, so we have to be very careful with this part. So we can look as, let's substitute t as a 5x, okay? And first let's look at t. So let's just find all the points between 0 and pi, because this is our interval, right, from 0 to pi. And let's find all the angles which has negative 1/2. Okay, we don't have any. Well, that's crazy. Right. So now, okay, that's so funny. Well, that's not funny, but we have to. Is it possible that? Of course, it's possible. I have some mistake. Probably I do, because as we look at the function, there is no possible answer, which is definitely not correct here. So just let me take a look what I did here. 2, right, 2 minus 1. Okay, what is the problem here? Well, it's obviously not my day, but let me just look here. Okay, now I know. Okay. Okay, I'm a bit not really focused today, sorry. So I know now, because we use 0 pi interval, but for 5x. So at this point, we don't use this, right? Because it's not for t. So I'm looking for t and not x. Okay, is it clear? Because x is between 0 and pi. But at this moment, I look at t, and t is totally different, right? So we don't know really the interval. What's going to be 40? Well, yeah, well, we can really see that. Okay, let's calculate it. So just let's multiply 0 and 5 pi, right? So we have totally different interval because it's between 0 and 5 pi. So I should just draw more here until I get 5 pi, which is exactly here. Okay, and now it's all right. So we have few negative 1/2. So it is going to be, this is like half. So here, 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 and here, right? Correct. 1, 2, 3, 4 points. Okay, so let's first try to read them. So sine equals to 1/2 for alpha pi for 30 degrees, so pi 6, right? So it's like here. Okay, so this is pi 6, and we need here, so we have okay, so this is okay. Let me do it nicely because it's exactly in the middle, so it's going to be here. Okay, this is going to be better now. So these points, okay, and now it's pi plus pi over 6, and here 2 pi minus pi 6. Okay, so pi plus pi 6 is going to be 6 pi. Then we have 2 pi minus pi 6 is going to be 2 is 12 minus 1 is 11 6 pi. Then we have 3 pi plus pi over 6, so it's 18 plus it's 19 over 6 pi. And here we would have 4 pi minus, so 24 minus 1 is going to be 23 over 6 pi. Okay, so this is t, and now because we want to have x, so we have to look what we have to do. Divided by 5, and t divided by 5 gives us x. So down here we are going to calculate x's. So 7/6 divided by 5 is 7 over 30 pi. Then we have 11 over 30 pi, and then we have 19 over 30 pi, and then we have 23 over 30 pi. Right, so we got the answer. I hope that my little mistake didn't confuse you, too much. This is just a proof for you that even trigonometric equations are not the easiest, and you have to pay attention to every little detail. And I have just proved it to you. So we have to be really careful, like, where are we, right? So I used another letter, so I used substitution for reading the angles, so also the interval changed. Okay, so that was very important lesson for us. Okay, just to pay attention, what is the interval, which letter we are looking at. All right, so this is the equation number 2, and we have time for one more. Okay, so let me just think what we can use here. Okay, I think we can use this one. Right, so equation number 3 is like this: 2 sine squared x minus 2 sine squared x times cosine x equals to 1 minus cosine x. Okay, and here we have interval, of course, for x, right? Okay, let's emphasize it here. emphasize it here. So the interval is for x. Okay, this is our equation. So of course, I think it's very easy. If you just take a look at it, we see that we have exactly the same expression in both expressions. So what we can do, we just can take it in front of the brackets. So take a look here. So we're going to get 1 minus cosine x equals to 1 minus cosine x. So we got exactly the same expression on both sides. Important is the formula for trigonometric 1, and just exchange sine squared x for cosine squared x, and then have an equation with only cosines, and eventually use substitution for cosine. But this is, I guess, pretty, not, it's much easier because we just get the same part on both sides. So now what we have to do, of course, not dividing anything, but we just take this part to the left side. Okay, let me just write it down. So the left side is unchanged. Then we have minus this part, and now we take this part in front of the brackets, in front of the whole expression. So we take this, and what we have left here is 2 sine x squared minus 1. Right, okay. And we have again multiplication, so we just equals those two brackets to 0, so we have cosine x equals to 1, or sine x squared equals to 1/2. We have to take a square root, and remember that if we take square root of a square, then we need to use absolute value. So absolute value of sorry well, of course there's going to be absolute value, but let's put it on the right side. So sine x is going to be equal to right now absolute value equals to 1 by square root of 2, which is exactly square root of 2 by 2, right? So we need to put the absolute value, because now we can get plus or minus. So sine x equals to plus or minus. Okay, that's very important. So be careful here, because we remember that sine x can be negative, so we can use negative signs. All right, so now we have two simple equations again, and we have to solve them. So with cosine, should be easy because we have 1, right? And look, it's very good because we have x, so we don't need to use any substitution. So cosine x, just to take a quick look, just to remind you, it starts here from 1 and then it's going here. Okay. Okay, so here we have 1. This is pi over 2, this is pi, and here we have 2 pi, right? And our interval is between 0 and 2 pi, so as we can see, we have 1 here for 0, and then 1 for 2 pi. So we have only 2 angles, which are really easy to read, or you might even remember that for 0 and for 2 pi we have cosine 1. And now for sine x, we need to look a bit more. So let's take a look at the function again. So let me just put here function. Okay. And we want to have sine x equals plus minus. Okay, and again from 0 to 2 pi interval. So this is our interval for x, right? That's very important, that we don't need to substitute x for something else. So we have just straight away x. Okay, so which angles have this sign? So I think, of course, that you know already. So it's 45 degrees. So pi over 4 has sine x equals to square root of 2 by 2. So where do we have pi over 4? So this is pi over 2, so like in the middle, right? So here, okay, and then here it's going to be pi over 2 plus pi over 4, so it is 2 plus 1, 3/4 pi. Okay, so there we go, this point, and of course we can have negatives, so we need to go here in the middle, right, and this point and this point, and it's going to be pi plus pi over 4, so it is I'm gonna just check if we have the good answers here. Yeah, so pi plus pi 4 is pi 5 pi over 4, and here we have 7 pi over 4, right? So use symmetry, we have exactly the same length here, so we just add this number, so add pi over 3 or subtract pi over 3. And so we have 4 angles, right? So we have, okay, let me just write it down, pi over 4, then we have 3/4 pi, 5/4 pi, and 7/4 pi. Okay, 1, 2, 3, 4 angles. All right, and this is the answer for this equation, right? And here we have these 2 points that we have to add together, so altogether the answer to the whole equation, we have 1, 2, 3, 4, 5, 6 points. So let me write them down together. So it's 0, pi 4, 3/4 pi. Really, it's really hard to read them in English, like 3/4 pi, 5/4 pi. Crazy. 7/4 pi and 2 pi. Okay, so there you go. Right, and this is the answer for this equation. I hope these 3 equations show you how different they can look like, and what different formulas you have to use to solve them, like the sum of the sinuses or substitution. But as you can see, we always try to get to the simple ones, right? So we try to use some formulas, maybe get something before the brackets, and then get to those simple equations, like here or here, right? We always get to some simple equations at the end. So this is the idea to do it, right? To get to the point where you have just very simple equation, and then you can go to the function and just read the points from the function. Of course, check the interval, and also just to remind you and myself, so if we use substitution, so if we have here something different than x, right? So we have 5x, or we can have x plus something like x plus pi thirds, right? So if you have anything here and you use substitution for t, okay, so we have to change the interval, okay? Then we have to change the interval, because it is going to change, right? So then we have to see that the interval changes, and then we don't look only for the first interval from 0 to pi, but we look from 0 to 5 pi, right? So this is very, very crucial. All right, and I think that's it. Thank you very, very much for watching. If you have maybe any other ideas for trigonometric equations, let me know, and we might try to solve them. Right, thank you very much, and bye-bye.